Hello, everyone. This is Mr. Win speaking here. If you are hearing this, I am off today going to get my vaccine, at least hunting for it anyway. Um, so, I'm going to give you a lesson here on this whiteboard for this video, and then I'm going to give you your homework. And you can use your time after the lesson to do the homework. So this is called asynchronous learning. So hopefully you guys can learn as much on this as you would in normal class. Of course, I'm not there to answer any of your questions or anything like that, or tell my strange jokes. So I guess I can just do that here, and hopefully you guys will um, learn as much. Anyway, what we're going to talk about today are powers, not supernatural and Marvel powers, but powers in math and exponents. Um, and today's date is going to be 3 2021. Okay, so I'm pretty sure some of you guys have heard of something like this before. So I'm just gonna break this down for you. Let's just say you have a number. Okay, I'm gonna give you a number. Let's try 2. And then you have this smaller number. Let's try 3. This is what this means. This is called a power, but I'm going to break down what this means. This large number down here, this is called your base. It's called a base because this is what you are going to multiply, the only number you are going to multiply. This number is called your exponent. Notice how it's smaller and it's just to the top right of the base. This number tells you how many times you are going to multiply the base. And the whole thing, the whole kit and caboodle, this is called a power. Okay? So here's how this works. 2 to the third power really means 2 times 2 times 2, 3 times. Notice here that the number of times that you multiply is the same number as the exponent. So this says that you should multiply the base 3 times, and that's what you do. You multiply the base by itself 3 times. Okay, 1, 2, and 3. Okay, once you do that, that's 2 times 2 is 4, 4 times 2 is 8. So there you go. The answer to this is 8. But more important than the actual answer is for you to understand what this whole power means. Now, a lot of people, myself included, use exponent and powers interchangeably. Like it will mean the same thing when I say, "Hey, put it as an exponent." What I mean to what I mean when I say that is basically I want something in this format. Okay, but technically the whole thing is called a power. Okay, so I'm gonna ask you to do a couple things. Well, this lesson is gonna be about a couple of things and manipulating the powers and the exponents. So let's just say first, what I want you to do is write uh, the product using an exponent. So we're going to do this for a while. Write the product using an exponent. So I'm going to give you the product of a bunch of things. So let's say 7 times 7 times 7 times 7 times 7. Now I want you to take this product and transform it into an exponent. So what is being multiplied? The only number that's being multiplied is 7. That becomes your base. How many times is it being multiplied? Let's see here. Let me put it in this red. How many times is it being multiplied? 1, 2, 3, 4, 5. So that is your exponent. So the proper way of saying this is 7 to the fifth power. 7 to the fifth power. Now, this exponent, there are special exponents, special numbers that has a special way of saying the exponent. I'm gonna give that to you in the next couple of examples here. So I'm gonna write this out. This means, oops, too big. 22. There you go. 22 is always the sweet spot. The 7 to the fifth fifth power. That's how you say it. Okay. Put quotes around it. Now, um, example 2. Let's say you have 18 times 18. Okay. So how many times is 18 being multiplied? Twice. What are you multiplying? 18, obviously. So it's 18 to the second power. You could say the same thing, 18 to the second power, but the proper way of saying this, the special way of saying this, is 18 squared. And we're going to talk a lot about squaring in a little bit. So there's two different things you could say about this. You could say 18 to the second power, or you can say, this is the more common way of saying it, 18 squared. Okay, anything to the power of 2, you could say squared. Okay, so if you see something like, I don't know, let's go with 7 again. 7 to the second power, you could say 7 squared. Or, 9 to the second power, that's 9 squared, and so on and so forth. So here's another one. Let's try 4 times 4 times 4. What's being multiplied? The only number that's there is 4, so that's your base. How many times is it being multiplied? Well, 3 times. So this is the correct way of saying this. This is 4 to the third power. You could say that. You could definitely say that. But the more common way you will hear this is 4 cubed. 4 cubed. Okay. And there's definite reasons why you would say squared and cubed, because square is basically a square. How do you find the area to a square? Well, if you have 18 over here and 18 over here, that's 18 times 18 for the area, right? So that's 18 squared because it is a square. Now, for a cubed, we're dealing with volume. So you have a three-dimensional figure. If you want to find the volume of a box, you have length times width times height. And if they're all the same number, that will become a cube. You guys get it? It's a cube. So that's why if you have, like, this is say L is equal to 4. Let's use 4 because we're using 4 already. If length is 4, width is 4, and height is 4, well, that's 4 times 4, oops, times 4 times 4. And that gives you volume. Okay, and volume will give you, sorry, volume is the reason why you would say 4 cubed, because you're multiplying the same number 3 times. Gives you a cube. Okay, so that's writing a product as an exponent. Now, what about the other way around? The other way around is example 4. Write the power as a product. This is going the other way. No, here. Okay, so writing a power as a product, we're going the other way around. So let's just say we have 15 to the fourth power. What this means is your base 15 is being multiplied 4 times because that's your exponent. So your base is 15, so you're multiplying it 4 times. And that's what you have to do. Write power as a product, that's what it looks like. Now, sometimes I'm going to ask you to multiply it out, and sometimes I won't. Let's try multiplying one out. And I'm not going to give you 15 because I'm not going to ask you to multiply 15 4 times. That's kind of absurd. So let's just say we have 3 to the fifth power. So we have 3, that's your base. You're going to multiply the base 5 times. Hmm. Okay. So that's 3 times 3 times 3 times 3 times 3. 5 times, right? So ultimately, you could do this. If you want to find out what the actual answer is when you multiply them all together, you have 3 times 3 is 9. And you still have 3 times 3 times 3. Now, 3 times 9 times 3 gives you 27. You still have that 3 times 3 there. 27 times 3 gives you 81 times 3. Then you multiply these two, then you have 243. So that's 243. That'll be your answer. Okay? So that's if you actually try to figure it out. And the what you call it? The book will ask you then find its value. When it says find its value, I want to put this in a big red box for you. When it says find its value, that's when you actually give the number. Otherwise, you don't. Okay? If it says just write the power as a product, I'm sorry, write the power as a product of the same factor, this is what you give. This is what you do. If it says write the power as a product of the same factor, this is what you do. But if it says then find its value, then you multiply everything. Okay, hopefully that's clear. Um, Here's an interesting one. Example 6. Yeah, let me move that down some. Let's get some space. Okay, what about this? About 2/3 to the third power. Oh, that's weird. So this is still the base. That's this 2/3 is the number that you're gonna multiply. How many times are you gonna multiply 2/3 by itself? 3 times. 3 times, right? That's how many times you're gonna multiply 2/3. So it's 2/3 times 2/3 times 2/3. Okay. So that's 2 times 2. And again, if they ask you just to write it as a product of the same, write the power as a product of the same factors, this is what you give it. But then if they ask you to tell you to find the value, you multiply 2 times 2 times 2, that gives you 8, and 3 times 3 times 3, that gives you 27. This will be your answer. Okay, hopefully that's clear, that this lesson is clear. We need to go over one last thing, and then we'll be done. There's something called perfect squares. Now, a square, as we talked about, perfect squares. Squares, as we talked about, is basically anything with the power of 2, like a number here to the second power. Okay. Now, I want you to try as best you're able to memorize a bunch of these, going to 100. Okay. So I'm going to give you an example. I'm not going to give you an example. I'm going to give you the list of numbers that are perfect squares. And it's very good if you memorize this. Here are perfect squares: 4, 9, 16, 25, 36, 49, 64, 81, 100. All of these numbers are perfect squares. Okay, I've just listed them out. Why are these perfect squares? Well, let me show you. These are perfect squares because 4 is 2 squared. So it's perfect, right? That's perfect. So meaning there's no decimals, there's nothing, there's no decimals, there's no fractions. It's just a nice, neat whole number. 9 is also perfect square because that's 3 squared. 16 is 4 squared. 25 is 5 squares. You see what I'm doing? I'm just kind of walking my way up the number all the way to 10. 2 squared, 3 squared, 4 squared, 5 squared. This would have to be what? 6 squared. This is 7 squared. This is 8 squared. And this is 9 squared. And this is 10 squared. Now, again, squared means a number by itself. You're multiplying a number by itself. So 8 times 8, because it's 8 squared, is 64. 9 times 9 is 81. So all of these are perfect squares. Okay? Hopefully that makes sense to you. Yeah. Hopefully that makes sense. But I think that's kind of all I want to go over today with perfect squares. So you can I can even ask you a question like this. Okay, the area for this square is 36 centimeters squared, and that's the area. I'm going to ask you, hey, what is the length of one side of the square? So if the area is 36, and we know that um, the area of a square is side times side, well, we're looking for a number that multiplies by itself to give you 36. So isn't that just 6? 6 times 6 will give me 36. So it'll be 6 centimeters. Okay, so I might give you a problem like this. If I gave you, so no, that's a bad square. So that's a square. Let's just say the area for this is, I don't know, 49 centimeters squared. What's the side? Well, it's 7 and 7, right? Because 7 times 7 gives me 49. Does that make sense? I hope it does. Anyway, that's it. I'm gonna give you your homework, and the homework is basically let me dig it up here. It's gonna be page 437. Homework is page 437, 7 through 439. Odds. And again, I'm gonna post this on PowerSchool for you guys to take a look at. Alrighty. Hopefully you guys have a good day. Bye now.